Okay, so I believe we can start now. So welcome everyone to the Greentech Investment Conference. I would like to welcome the pitching startups. Welcome to the advisory board members and to all the other attendees. My name is Mathilde Vade and I organize pitch nights, investment conferences and private investor calls at the Startup Club on the topic of fashion, beauty and green tech, introducing advisors and investors to selected startups during our online events. So tonight I'm happy to introduce you to two startups. The first one is called Sound Energy, turning waste heat into cooling using thermoacoustic technology, presented by Herbert Berkhout and Ron Wagterveld from the Netherlands. Can you all hear me all right?
Yes, we can.
Okay, great, thank you. And the second startup of the evening is called New Paradigm Energy, delivering clean energy solutions to achieve energy independence. And this pitch will be presented by co-CEO Brandon Boucher from Boston, USA. I'm sorry to announce that this third startup, Solaxi Group, will not be pitching tonight, but they will be joining the next session, which will be in May. So I'm really looking forward to listen to these pitches and learn more about these green tech startups. And now I would like to introduce you to the format of the event. Each startup has 5 to 7 minutes to pitch, followed by 15 to 20 minutes feedback from the board members. And anyone can use the chat to ask questions to the presenters and also to network during the event. And now a few words about the Startup Club before we start with the first pitch. The Startup Club is a one-stop shop for the global entrepreneur community. Our vision is to assist businesses in their capital structuring and growth by connecting entrepreneurs with investors, advisors, mentors, and other key players in the startup ecosystem internationally. And through a series of pitch night and investor networking conferences, the Startup Club helps startup scale-ups and growing companies to reach their funding and development needs. And in 2021, we hosted over 50 successful events attended by numerous angel groups, high net worth investors, VCs, private equity funds, and other investment professionals. With active presence across all continents, we have over 70,000 members in our online network. And the Startup Club works across different industries such as green tech, fintech, real estate, food tech, ed tech, fashion tech, beauty tech, healthcare, and much more. If you would like to learn more, I would invite you to check out our website and where you can also stay updated about all our upcoming events and other services. So now I would like to welcome the board of the advisory board members, and I would like to ask them if they could shortly introduce themselves. I'm very happy to welcome you here tonight. Hélène, would you like to introduce yourself first?
Sure. Hi, my name is Hélène Thibieroz. I created the WeGrowGreen Tech. It's a green technology accelerator and incubator. We have worked with between 50 and 70 startups in the green technology space in the last 5 years, working in energy, advanced material, biotechnology, waste economy. So I'm glad to be part of this judge today to kind of review these two companies.
Thank you. Welcome, Hélène.
Thank you.
Glad to have you here. Mirjana from the Founders Institute. Would you like to introduce yourself? Hello.
Yes. Hi. Hello.
Hi.
Hello to everybody. So my name is Mirjana and I am based between Brussels and New York. I have almost 20 years of experience working for the European Union and almost 10 years being a tech entrepreneur. And now we are launching Founder Institute, which is an early stage tech accelerator from Silicon Valley in Brussels. So feel free to check that information. And I will also add my LinkedIn profile here in the chat if you want to add me. So thank you so much for the invitation and happy to be part of this conference.
Thank you so much. Leticia, would you like to introduce yourself?
Thank you. Yes, of course. So my name is Leticia. I work at Plug and Play Ventures. Plug and Play, we're an early stage VC, and as well, we're a corporate innovation platform where we're connecting startups to corporate partners to entail business development opportunities. I work for the fintech and enterprise tech sectors, but I've been focusing quite a lot on sustainability. It's great to be here. Thank you so much for the invitation. And I'll also leave my LinkedIn profile in case anyone wants to add me. Thanks.
Thank you, Letitia. Welcome. And we have also Anne-Sophie Winter Hansen from Denmark. Hi, Anne-Sophie.
Hi, Mathilde, and hi, everyone. Really happy to be joining. So my name is Anne-Sophie, and I'm with the Danish Sovereign Investment Fund, based out of Copenhagen, Denmark. We invest equity and do loan financing for startups in different stages, either based in Denmark or expanding to Denmark. It's really excited to be here and to meet the startups today.
Thank you so much. Thank you for the introductions. Now I believe we can move to the first pitch. So I remind you that if you have any questions to the presenters, you can use the general chat or a private message to get in touch. And now I would like to give the floor to Herbert and Ron from Sound Energy. So hello, Ron and Herbert. Happy to have you here tonight.
Hello, Mathilde.
Hello.
I'm taking care of the pitch today. Ron is not available, so I will do the job.
Wonderful. You can share your screen and you can go ahead with your pitch.
Yes, we will see if it. I cannot start sharing if other people are sharing. So
yes, okay.
Maybe.
Now.
Yes, I will try. Yes. Okay, thank you. Welcome at the pitch from Sound Energy, turning waste heat into profit for free. What we are doing is solving the problem of waste heat of the production industry. Energy costs are rising, and in a lot of production processes, there is waste heat available, while there's also a cooling need. And instead of using the energy which is coming out of the waste heat, a lot of companies are paying a lot of money to cool by electric chillers. And the demand of cooling worldwide is huge, and the amount of waste heat available is also very big. So why not reuse the waste heat and turn it into cooling and have an attractive business case? And the business case gets more and more interesting because carbon is also taxed more and more in Europe. So you will always get a punishment if you don't reuse your energy and you don't reuse, in this case, your waste heat. You get actually carbon taxes, which is making your business case less strong. Well, we have a patented solution for it. We can turn waste heat into cooling by turning it first into sound waves, and the sound waves can make a cooling step for your process cooling. For example, in factories for food, for metal to cool it. In this case, we can also use it for office cooling. So you can save a lot of money on your electric chiller or your electric air conditioning, as we say, if you use your waste heat and turn it straight into usable cooling. It's a big market. We just show you that it's a 120 million plus market available. I'm talking now only about the let's say the industrial cooling need, and also about the waste heat available. So yeah, it's a really big market where we think we can get our share. Well, we have a patented product, and it is an easy fit. It means that we can connect very easy to the existing systems. It's a fully fluid-driven system. So we're using only components which are standardized and available in the industry. So there are not needed any expensive changes or investments. We can easily plug and play our machine into the existing environment of the factory. Here we give a schematic overview. Let's say, here you can see, this is our machine, it's a ring. It will feed it with a 180 to 300 degrees Celsius heat. It will give till -30 or ambient temperature output. And of course, thermodynamics means that you always have to get rid of your own waste heat, let's say. So 50% will be used for cooling and 50% will still be thrown out. But that is very easy to do that. So it will not cost you so much of your business case. I'm not going to show the video because then we will running out of time, but we have a video available on the website, and it can tell you a very interesting business case of cooling of a coffee roasting company. We reused the heat from the coffee roasting for the office. So in summer and winter, they now have their own heat using for climatizing their office building. Here you're going to see an example of we can easily scale up. We have a 25 kilowatt machine, which you saw in the beginning, and a 200 kilowatt machine is available in 2 sea containers. And you even can scale it to 1 megawatt by placing 5 on top of each other. And you can also serve, in this case, for example, the maritime industry or process industry. We have 3 business cases, like I said already, the Mocador case. We have a school that we are cooling on top of the building. And the third one is our distributor in Japan, which has his first business case in the foundry industry. So let's say the metal pouring, the die casting industry for the automotive. There's also a lot of waste heat available for the, let's say, for liquefying the metal. And then afterwards, you need cooling for hardening the metals, for ball bearings, etc. And we have now our Japanese distributor who will introduce the machine on the Japanese market, and it's running fluently there. We are award winning, but I will not spend too much time on that one. If you take a look at the competition, you have organic ranking cycle, absorption chillers, electric chillers. They all have their minuses and their pluses, but it turns out that we have better performance in the sustainability, and we have less energy costs, for example. So that's why we are challenging them. We have a high ROE, fast return of investment. We have low maintenance, a long lifespan, and it's patented. So those are 4 of our most important pluses. If you take a look at the investment, we are looking for a 2.4 million investment round at the moment. 50% by fresh capital from venture capital, and 50 will be matched by a regional fund. And that we will use to produce the first 200 kilowatt machine to enter the markets and be more cost efficient. This is how we will spend our B round. And it says a bit of how we got to the first 3 million, which we used to get this so far as we are. But of course, the HVAC market is a very capital intensive market. So we use this 2.4 for 18 months. Here we say something about our timeline. This is the team that's working on it. Ron cannot be there, so that's why I'm doing the pitch today. And we're very proud of our advisory board, which is like 3 mature entrepreneurs who are very deep into the technology, and they are very helpful, for example, in the maritime industry for us. So thank you for having me.
Thank you so much, Herbert. Great pitch. Wonderful. We can now move to the feedback. So Laetitia, would you like to start?
Sure, thank you. And thank you very much for the pitch. It was great. So in terms of feedback itself, I think the technology is super interesting. Of course, like a couple of years ago, Cleantech wasn't like that mainstream, but now in the current environment where like the decarbonization of like heavy industries is like becoming so important, like this kind of products can be really come at hand. For many investors like us, we think about it, and many of like these waste heat methodologies and systems can provide solutions for the outcomes of all these different industries. But it's also interesting to think about ways to prevent these outcomes themselves. So I would also kind of like think about it whenever you look at the strategy itself. I am curious to understand a bit more about your business model in one of your slides where you talk about it. You mentioned it, but I wanted to understand whether it includes upfront cost and or if it also includes like a recurring revenue from the energy output, plus the operations and maintenance. So I don't know if you can talk a bit more about the business model itself.
Yes, let's say the purchase of the machine is about 40K. And because if you look at what you will get cooling for, let's say 6 degrees, cooling for your HVAC, normally like a chiller. Normally this chiller would use electric power, and electric power more and more gets expensive. So you actually first you are saving on your electric cost on the electric chiller. On the second, you will also have less cost on maintenance, because normally on electric chiller it's full of freon kind of gases, and it will be done with high paid technicians to take care of it yearly. Everybody who knows about air conditioning, they are very expensive in the maintenance. Because our machine has no freon or any of those gases available, we have a very cheap, let's say, maintenance system. And the second is we don't have any moving parts. So in an air conditioning, you have a compressor. Compressor is like steel to steel, so it has a lot of wear. It's every 5 years you have to change it. Because we only have gas, and actually the compressor is changed from let's say a sound wave. The sound wave is doing the compression. That's why we have such a maintenance-free machine. And because it has no wear, it has no maintenance, and it has also no aggressive gases, no toxic gases, and also not gases which will oxidizing. We also have a lifespan of 30 years, and that's at least double of the electric chiller. So in this case, you have a one-time investment, and you earn back your investment in 7 years because of the advantages that I just told you.
Amazing. Thank you very much. It's super, super interesting. I'm just curious to understand also about the ease of retrofitting. Like, for example, you mentioned use cases like office cooling. So how would you, like, where would you put your product in an office, for example?
Yes, in the office, normally on the top of the building, you have your installation. There you have, for example, I always, for me, it's always difficult to have the English name, but it's the air handling machine, or the air handling box. There you actually put in your cold liquid to make it cold ventilating air, and put new air and ventilating cold air in your building. At that place, we can plug our machine in. Because our machine is also fluid driven. It means that on the output you get cold fluid of 6 degrees, for example. You can straight connect it to your air handling machine, and the air handling machine works as in a normal office already. So if you have the waste heat from the factory available nearby, you can get your cooling straight connected to the place where you also would connect it if you have an electric chiller. So with retrofit, it will make no difference.
Amazing, makes sense. Well, thank you very much. We work with a bunch of corporate partners in all different industries, and of course, like this kind of like heavy asset industries as well. And this kind of product makes a lot of sense. So thank you for your time. I won't take more time.
Okay.
Thanks.
Thank you.
Thank you so much, Leticia. Hélène, would you like to be next?
Sure. So pleasure to meet you. A couple of questions, mostly on the technology side. How is the IP protected in terms of patent, trademark? I mean, I didn't see too much information on the presentation.
Yes, we had a patent on the technology, and which is especially on the inside of the vessels, and it was lasting to 2018 because it's already 20 years old. But in the meanwhile, the last 20 years, we changed a lot and we made a lot of development. So we asked for a new patent, but more, let's say, a patent built on all the changes and all the new knowledge that we gained in the last 20 years. So it's not a patent purely on one aspect of the technology, thermoacoustics, but more a patent on the combination of all the knowledge that we have. So that's to protect the current machine. but we also have patent for the next 20 years on making the machine more efficient. And that means that every vessel that you see here, the gray vessel, will be turned 90 degrees. So it will be placed in the same length as the circle, and the sound wave will go through it in a different way, more horizontal than now vertical. And it will make the machine smaller, and it will make the machine more efficient. And we will have for the next 20 years a patent on that one worldwide. It's a novelty.
Very interesting. So when I look at your business development, you're already approaching other countries. So you had a process in place to protect your IP,
Yes.
right? Because it can get pretty complicated very quickly. So that's my question on this one. And the other one, in terms of application, have you looked at data centers?
Yes, but the data centers themselves, they produce like 50 or 60 degrees heat, so that's not enough. We need 200. So only if there's nearby anything like an electric station or there's nearby heavy industry where you have, let's say, at least a chimney with 200 degrees air coming out, then we can combine it. So that
Got it. So my question was more on the technology side. If you think at some point it could be applicable, you could reach to lower type of temperature, because I think I've seen a lot of technology solution trying to improve, like heat problem for computers is a source of, it's a loss of energy. So I was just curious if there will be any possible application in the future.
Our machine is driving on heat of, let's say, 200 degrees. So maybe we can get more efficient on a lower temperature, but that's of course a lot of research, and that's not a sure outcome. So at the moment we fully focusing on the temperatures that are available. So for example, yesterday I was talking to Honda Innovations in California. They have a lot of production plants, and in those production plants they have a lot of heat of 200 degrees available. And we hope to get from them half of May an order to place one machine in one of their Tokyo production plants. So I think at the moment there's a lot in the temperature range that we're now focusing on. There's a lot of business opportunities.
And have you also think, because it was really interesting, you make it everything more efficient, obviously, right? So it's like result in energy saving as well. Have you thought about also trying to kind of look into energy saving, how it will convert into carbon economy? Like if you save energy, that's less CO2, right? And then so with the emergence of a very strong carbon economy, if you look at the price of a ton of carbon that keeps kind of exponentially increasing, I'm wondering if you start looking into that to further entice corporation to use your solution, because then they can get carbon credit, right? If you can enable your solution.
Yeah, so at the moment we're looking at the food industry, at the heavy industry, process industry, and maritime, because there are the highest energy levels available, and also there are the highest cooling need. So we always need heat and cold together.
Correct. And if you look, that's why I think it's really interesting. If you look at metal, aluminium, for example, right, create a lot of pollution.
Yes. Cement also, yes.
Exactly, right?
Yes.
That's because I've been working on this in the last year. So if you make this company, this corporation more efficient, and I think if you can tie it back to CO2, because they're gonna be really strongly impacted by CO2 regulation. Yes. I think you can add a very interesting value proposition there in your presentation.
True. It will even get a lower return of investment.
Exactly.
Because they also save on the taxes. That's true.
Correct, especially cement industries that are going to be stuck at some point because of the regulation that they have to face.
Yes. Same with raisins. We are now talking to big raisin companies. To make a raisin out of plastic or out of materials, it's often above 200, 300 degrees to produce it, and you have to cool it down in the process. Right. And we can straight cool it down with the same energy that you're losing of producing it.
Yeah, so you may start to look into that in terms of when you approach company, because maybe it will resonate even more, kind of to further position the technology.
Yes, last week I had a phone call from Lay's, the PepsiCo company, also because of making their chips. And 2 years ago, for them, it was not so urgent. And now with the high energy prices, they heat up oil and run oil ovens. and they want to really have a returning on their energy. The same last week, I heard the same phone call from Shell, also on one of their plants. They want to now cool the office building with our technology, so that the heat that's available from production of, in this case, oil, that they can straight cool the office with it.
Oh, for sure. I think with the dynamic that you see today, I think there's a lot of pipeline.
The phone keeps ringing, but of course I have to be honest. In business to business, it's a 2-year horizon. For example, we got a phone call from this coffee roasting machine, let's say in 2018, and in 2020 we shaked hands and we really got the payment. So it's a 2-year.
That's a long. Corporation is always long.
I have to be honest, that's always, and we don't mind, because we know, for example, now we're talking to a shipbuilding company and they talk about a vessel that has to be ready in 2025, and now we have to get on board because in 3 years we are too late. So now we have to talk to them and know that in 2025 our machine will be built into their vessel. So we have to do it now. So we know that we have long horizons. That's why we need this large investment.
So what's your plan in terms of manufacturing there? Do you want to create your own manufacturing, or do you want to eventually license?
No, till now on we work all the time with third parties for production in the Netherlands. But for example, with Japan, with Sinterkogyo, this company, we already are drafted IP contract. They have a distributor contract, and we decided if they buy more than 50 machines from us, they will get their own license agreement, and they can start building their machine. And we get not only, I have to say, we get 7% of the sales, and for doing nothing. So that's really nice.
Or you do a joint venture with technology. Yes. I mean, there's different approach you can. That's why I think you have to be careful about your IP. Make sure you protect it everywhere, and it could become really like a big job. So thank you, great presentation.
Thank you very much. Thank you.
Thank you, Hélène. Mirjana, would you like to give your feedback now?
Yes, hi, thank you so much for this pitch. I agree with Letizia that Greentech is now really topical, and especially everything to do with carbon, at the EU level, like all the legislation is going towards that direction to regulate this area. So I would have a few questions for you. The first one is, which market are you going after? Because I imagine you're starting in the Netherlands, and then you mentioned the US, you mentioned Japan. Is this structured in any way? And I would also ask, you mentioned 3 competitors. Do you have any direct competitors? And what is your, unique value proposition?
Okay, yes, we think that we should start. We already started in the Netherlands, because it's every B2B sales. It's not from the catalog. It's not from the website. They want to talk to you constantly. They want to see the machine. They want to feel it. They want to have the feeling that if something goes wrong, that you're available. So the fact that we have already several sales in the Netherlands is really helpful. That's also the reason why the Japanese wanted to continue with us, because they saw that we had a machine running already in the Netherlands and they could feel it, they could see us. They visited us 3 times. Because of the COVID, we were literally sitting on our hands because nobody could visit us and we could not visit anybody else. So this is not a machine that you buy from the catalog. So that's why we started first the home market. And of course, the home market is not so is smaller, but it will give you a good demos. And from that place, we try to continue to more let's say in the areas in Germany and Belgium, where you have a lot of heavy industry. So if you look at the Ruhrgebiet in Germany, if you look a bit more in south of Germany, that's still you can drive this in 1 day. These are the region that we're looking at. At the same time, we're talking to Honda, for example. We're talking to Chinese companies. We're talking to big American companies, because if we can find a matchmaker and somebody who would like to initiate introduction in a different area, we are of course willing to do that. But our own effort, we put in, let's say, the 600 kilometers around the Netherlands where we are now, because we have to be present. It is like, say, B2B business, and it's relation marketing. We have to talk to them frequently. So that's our strategy. That's the only way that works.
And in comparison with the three competitors, why
Yes.
are you better? Is it also your revenue model, or in which way are you better?
Partly technical, I think I can show you. Yeah, this one. Partly technical, because for example, electric chillers, I told already, they have a lot of moving parts and electricity is expensive. So it is, let's say, it has a very high global warming potential. So it's also expensive in the taxes, let's say, and you have a high energy cost. So the electric chillers are really here. The organic ranking cycle has also still a lot of a high GWP. This is global warming potential. It means that it's not so sustainable. And if you take a look on the absorption chiller, they also produce cooling, but at the same they are closer already to the global warming potential, and still they have still high energy costs because they work with a vacuum. And the same is absorption technology is also working with a batch process, and they are not so flexible in different temperatures. So we are more an analog machine. It means that if you offer us 160 degrees, it also will work. If you offer the machine 300 degrees, it also will work. It's even getting more efficient. If you use an absorption chiller, you can also turn heat into cold, but you can only have a very small temperature window, let's say a delta T of 20. If it goes too high or too low, the machine has to start a new batch process because it's purely chemical. And it means that you lose a lot of efficiency. So that's why we, in all of those three cases, we are, let's say, the best solution.
And what is your revenue model? How will you make money for your investors?
Till now on, it's just plain hard sales. But we are thinking of pre-financing it because the machine has no let's say no maintenance, and it's pretty easy to build because it's just very simple steel parts and a little bit of fluid circuits. It means that we don't mind to just rent it to companies because we know it will work flawless. So why would we sell it and rather rent it to other companies? So we are now looking for a rental model that they only pay for the cold that they get, and that they pay less, and that we share the savings, let's say, like a cooling as a service model.
Mm-hmm. And what are your current biggest challenges that you are facing right now?
The long lead times. So companies, if you talk to them today, in 2 years you will have sales. Now, for example, we're talking now to Honda and yesterday, and they showed me that they want to order the machine in May. But of course, there are a lot of things can happen till May, and if they don't order, it will take a longer lead time. Some companies want to go fast, and then it can be done in half a year. But it's like say the prepay, let's say the financing of the gap of production. And of course, we want to make the production much more serial because now every vessel is made by hand. It's very expensive. It's all done welding by hand. It's very expensive. If we would make thousands of those vessels at the same time with a welding robot, it would be so much cheaper. So we love to scale, and we love to, let's say, do the production more automatized.
Okay, so what will you do to overcome this challenge of like long leads?
Make the leads lower by very good information. Also, be very selective on the leads. So on the first day, I straight send them a questionnaire, and if it turns out that there are some, it's not the perfect lead, then we say goodbye pretty fast because we know now which our preferred customers are and the people who will never buy from us. So we are pretty strong in selecting where we put where we will put the effort and where we will just say goodbye fast.
Okay, and my final question, what is your end business goal? Where do you see yourself like 5 years from now?
I hope that we have a lot of countries where we have IP contracts and where they themselves produce the machines, and that we are taking care of the development, the let's say the technology, make it more perfect, making new models, new sizes, entering new markets, but that we will have a worldwide network of let's say manufacturers who are manufacturing the machine for us in in let's say IP contracts.
Okay, thank you so much.
Welcome.
Thank you, Mirjana. Anne-Sophie?
Hi, and yeah, thanks, Albert, for a great presentation. It's a really attractive market and really exciting technology going. I think a couple of questions of the comments so far have gone towards the avoidance of carbon emissions and potential business models there. But energy efficiency is so important. It's been going on for years across several industries and sectors, and most of the large industrial customers that you'll be talking to will know that saving energy equals saving money, especially in the market that we're in right now. So I think it's a really, really compelling case. My first question is regarding technology readiness level. So you have a system now, and it seems like you've been deploying them a couple of places. And then you talked about a new system where you turn part of the hardware components 90 degrees. So it sounds like you have a product line planned. So could you perhaps give a couple of comments towards where you are with the product that's in the market now, what you have upcoming, and what it will require in research and development and testing all to get there?
Yes, that's a good question. We have, let's say, now the machine commercially available. You see the ring, but we also have it available in one container. Then it will be not a ring but a U shape, but it has almost the same, let's say, output. And we see that this machine needs a lot of plumbing, let's say, and the container machine is really plug and play. We have everything on board, pumps, some special equipment, everything on board to have it in plug and play running. You only need, let's say, 6 connectors and connect it to your factory, and it runs. And this machine is, let's say, most attracted by the customers. So only if you don't have space to place a container, or you don't want to place it on your roof, then people will choose the ring. But the ring is actually, let's say, the bare component, the component without a casing. So the machine is commercially available, and we sold already 6 of them. So, but still, the production, we would like to automatize it and make it bigger.
Yeah.
In case of development, we can make two tracks. One track is make a bigger one, so scale it. And let's say a 200 kilowatt machine would be very interesting, for example, for the let's say the chemical industry, process industry, and also for the heavy metal of heavy industry and the maritime. So that's the way to go. And the other way to go is keep in the area of the food industry for the smaller machine, but make it more efficient, like I told, with this changing of the machine 19 degrees. Yeah. Then also it will become cheaper, because then you don't need 4 loose vessels and 4 tubes. It will be one big tube with those vessels inside, and you don't have this 19 degrees connection, which is always in metal, the most expensive connection, because it's the weakest. Yeah. So then we can make the 25 kilowatt machine at lower cost and easier to make. But till now on, we think that we should just scale the machine and make it bigger. Then you have a 200 kilowatt machine is less expensive to build than, let's say, 8 of those 25s to compare it. And we save more money. You only have to install it once, and you save relatively more money than when you install a small machine. So until now on, we think we should make the machine bigger to save on the installation, to save on the cost of the machine, and serve even bigger markets.
Okay. My next question was towards the number of sold units, but you already disclosed that, yes, that you've sold 6 units so far. Yes. How does your order book look at this stage? Can you elaborate on that?
There is no order, let's say, assigned, like that we have a number 7 ready for making, but that's typical in the HVAC industry. Even if they tell you, if you shake hands and they tell you we're going to buy one machine, they wait 3 months before they have to install it, or even less. Because normally the installer is only buying the hardware 2 months or 1 month or 3 months in front of installing it literally on the roof. So even if you have already a done deal, it doesn't mean that you get your money. The money is only coming at the moment that the ordering is active, and the ordering is always depending on the moment that they want to have to really install it on the roof.
That's the payment profile. Do you have like a down payment on the order and then a factory acceptance test and a site acceptance test, or is it just when it's?
Yes, we do a lot. Like, for example, I was less than half year ago, I was called to the NUS, National University of Singapore. They want to have a machine. The same day they add me to a WhatsApp group to make it really fast. The lawyers, the procurement, everybody was in the app group, and assistant professors, and they want to make it fast. And at the end, 3 months later, there was no place on the roof, and they canceled the order.
Okay.
So even if they want to go fast in HVAC, you can find a lot of, let's say hurdles. At the end, I even spoke to the, now how he's called, I think it's a deputy president, that's the highest in rank after the president, and they say money is not a problem. No, money was not the problem, it was the space at that moment. So now we have to wait that they will find a new building which they want to use for cooling. We got already the IP contract. They want to do research on the materials, making more. So everything was yes. But they straight said, we're going to not make a down payment, because that's not what our National University of Singapore is doing. Okay. We can only pay 50% at shipping and 50% at the moment that it's running on the roof. So those big companies, they have a very strong position, and you have to swallow totally their, let's say, their rules. You cannot say, then we're not going to sell you. But so in this case, HVAC is really, it's a big market with strong players. Everybody is pre-financing it, like the carriers of this world. They're pre-financing it till death almost. So to get in there is really hard. That's the truth. Yeah.
You mentioned that you don't use freon, you don't use any expensive gases. Do you have any components containing rare earth metals or other, bottlenecks in your supply chain that you need to be aware of?
Yes,
as you scale the business?
Yes, we have the vessels are made out of metal, but it's only 11.5 bar running in there, working as argon. Argon is of course freely available in the air, and even you and me, we can fill a bottle of argon if we would like to. There's no regulations for that. It's not dangerous or anything. So the machine is filled with argon, and but 11.5 bar is not so exciting. Your espresso machine has the same pressure, even more sometimes. So we would love to make it out of plastics, and that of course it will take, I think, 3 to 5 years. But if we would have the money and we would have the available resources or the company, then I would love to make the machine out of smart plastics, maybe even lighter, using air technologies. But yeah, in this case, metal is an easy material, but it's also pretty dumb. So we would love to make the next step in development in making it out of plastic and cast it or anything. But till now on, if we want to move quick to the market, we have to stay with the dumb metal.
What about composite materials?
Yeah, composite would be perfect. We would love to work with it, but it's expensive. And especially metal is already known for a long time, and even to get all the regulations. For example, now we work with the CE brand, but when we start exporting to Japan, we need to use the Japanese industry standard, and it's much stiffer. It's much more requirements. They want to much more know how the metal is behaving on every part, how the welds are doing. 100% needs to be röntgened to see if they are well welded. So yeah, metal is already a difficult material. So we would really love to a smarter material.
Okay, I think my final question would be, earlier in your presentation, you mentioned that you need heat around 200 degrees Celsius. And you also mentioned that the market for industrial cooling is around 120 million. Mm-hmm. So how large a part of the industrial cooling market has heat of 200 degrees available for you?
Yeah, that's a $1 billion market. There's a lot of companies. I'm not sure if I have it written clearly somewhere. 87% of manufacturing plants have sufficient heat available. So that's like almost yeah, this amount of those plants in the markets that we're looking at do have waste heat available. So that would at least give us the possibility to sell one machine. And often,
but when you say waste heat, is that at 200 degrees, or might it
yes,
be, you know,
yes,
60
yes.
degrees? Okay.
No, then we're talking only about the levels of plus 200. So actually, everywhere where you're burning diesel or you're burning a liquid gas, then we have a business case. Even with the genset was producing electricity. Even we would have a business case in a truck. But of course, the machine is too heavy for a truck. It's too heavy for automotives, but we would have a business case there. So there's so much waste heat available in this plus 200, and sometimes even companies come to us and they say we have 1100 degrees. We say, oh, that's a bit too much. But so
okay, good.
It's really a huge market.
Yeah, great. Thank you so much.
Okay.
Thank you so much, everyone. Herbert. You have several questions in the chat. You can look at them now. Thank you so much. And you can share your website also and your contact details. That would be great.
Yes. Okay.
So yeah. So now we will move to the second pitch of the evening. I would like to introduce you to Brandon Boucher from the US, who is pitching for new paradigm energy. So hi, Brandon. Welcome.
I should unmute. There we go.
Hello.
Hello.
You can share your screen now and you can start your pitch.
All right. There we go. So my name is Brandon Boucher. I am the co-CEO of New Paradigm Energy. We are a unified energy generation company that is providing solutions for energy independence that can be scaled globally. The problem, everybody knows, it's a 100-year-old energy paradigm. There's ever increasing demands. The costs are way bigger, and we're basically buying from cartels that have a longstanding monopoly, and it's just overproduction. So what New Paradigm Energy does, we deliver clean energy solutions to actually achieve energy independence. We transform energy generation. We add resiliency and reliability to the actual system, as well as taking the entire energy production off grid. We do this by a 4-tier system. We use clean energy generation, which is highly efficient. We can use anything from solar, micro hydro, small wind. There's a bunch of different technologies that we have access to and that we have ownership of. We use smart controllers, which actually create using machine learning and AI technology. We can actually take a grid and actually make it robust, resilient. It does real-time monitoring. It can shift power over to other sectors. And the really cool thing is that we can put these together, and that if there is one system that fails, then it just isolates that, and the rest of the system continues to actually generate efficiency or electricity. We do load efficiency, line conditioning, as well as power signal correction, and all of this we have on-demand storage with long duration storage that actually produces, or that is actually used with non-lithium ion batteries, so that we have predictable power, and businesses have been looking for a solution that is cleaner and can actually utilize what they currently have. Everything is a decentralized model. We've got load efficiency, clean generation, energy storage. That all goes into the smart controller. The smart controller then actually creates a organic and homogenized system, so that we can actually produce these with current technologies. We can use fuel cells, green hydrogen, compressed air, biomass. We have access to over 7 different technologies. We also have a large number of battery storage companies that we've partnered with to give us the most flexibility for this system. The great thing, as I actually talked about, we can actually make these systems smart and talk to each other, so that if there is a problem, it can self-regulate and then actually isolate if there is a catastrophic failure. We can actually do this by one of our commercial innovations is our small wind turbine. It's a small footprint, 25 square feet, and it can produce our commercial model can actually produce between 14 and 18 kilowatts. They're actually rated. We're also working on getting up to a 20 kilowatt rating. And we are considered the small wind as long as we stay under 25. And the great thing about what we actually do, is that it is a dual axis turbine. So there's two generators producing twice the amount of power in a very small space. We've got international traction in both Mexico and Tunisia. We've got private and public sector interest. We've got LOIs and soon to be purchase orders for both the F1 racetrack and the hospitality sector in Mexico that actually is 70 plus hotels and casinos across LATAM. We're doing a proof of concept at their smallest hotel, which is located in Tijuana. We also have US traction. We have at the Schroff Center in Boston. We are looking to move this from proposal. We should get word by May as to whether or not we actually have this, which is fantastic. We do have a unit being installed next week at a test platform that will help us get the actual real world data sets. So this is our turbine. It can produce 310 watts per square foot installed. The platform is only 25 square feet. It is a dual axis, vertical axis wind turbine. It's got a life cycle of between 40 and 50 years. It's ultra low startup speed. We can actually produce energy at 2.5 feet or at 2.5 miles per hour. We have flexible installation as well as patent pending. This is also a turbine that is rated for 160 mile an hour winds. And the great thing about what we do is we stand 10 meters high as opposed to any of the other ones. So we actually work in the turbulent wind space. We're also omnidirectional, so we can actually spin towards where the wind is coming from. We can actually combine with current infrastructure, so we can increase the solar output of a solar farm by 2 to 4 times with just one installation. There's just a lot there. This is our Cat 5X. It stands 6 feet tall. The base is 6 feet. So, and then to the right is our smaller, smaller commercial model, and that is 6 feet by 4 feet high. We have a wind tunnel test that I can't show the video for. It's just way too long, but it would be really neat if I could. You guys would really enjoy it. Not quite sure what happened there. Wow. All right, no, I don't want to do that. Oh. Okay. And the reason we can produce so much power is because of this particular alternator, which is a brand new innovation. It is a ultra low friction maglev alternator. It's got frictionless cogging. There's low vibration, exceptional heat management. It's got no moving parts aside from the coil and the actual magnets. So it produces a vast amount of power in a very small space. Right now, our power rating for the Cat 5X is 16 kilowatts, and that actually has two 8-kilowatt generators on it. Annual output is conservatively 12,000 kilowatt hours per year. That's the average wind speed of about 12 miles, and we can survive 160, actually, not 150. And then you can see competitors here can't really compare to what we can do because of our small footprint and double turbine rating. Our business process is long. Again, the horizon is anywhere from one to 2 years, but we're getting to a point now where we need to start scaling up because the LOIs and POs that are coming in are incredibly large. This is our team. We have on this team, we've got over 250 years worth of experience in the clean tech and business development world. Our projections for year 1 to year 5, in year 5, where our net revenues are about $268 million, and revenue or our gross margins are, we have really good margins for everything going forward. Well, numbers speak for itself. These are what our projections are based on current goals. We're looking for $8.5 million to acquire some more IP, scale up current manufacturing, and supercharge business development, so that we can bring our footprint and manufacturing plan to developing countries. What makes us a solid market player and disruptor? We can enable energy independence by harnessing the power within nature. We use a integrated and modular approach, combining all of the correct systems that fit the client's need. And we believe that that the current centralized distribution model is broken, and people want to invest in their own energy independence and give them security moving forward. And that's all I got. That was a little longer than I was anticipating.
Thank you so much. It was really interesting. Would you like to share maybe the link to the video in the chat, if you have it?
Yeah.
Oh, yeah.
Oh, there we go.
Okay. Well, so Laetitia, would you like to start giving your feedback?
Yes, thank you very much. And thank you, Brandon. Super interesting. Congratulations on the pitch. It was very, very cool. I think, of course, like this type of technologies is kind of like key right now, especially because of the like wave to go towards renewable energies. And of course, from what you've shown, it seems like your product is like way more efficient than the traditional infrastructure right now. I'm curious to understand whether like you're planning on only offering this product for like new projects, or you're actually planning on replacing the existing ones. Like, so for example, for the turbine itself, like, are you planning on like changing the existing turbines? And if so, like, how are you planning on doing that?
Actually, that's a great question. So we can actually connect to existing infrastructure so that if there are solar farms out there, we can, without shrinking their carbon or without increasing their carbon footprint, we can actually help. By removing 1 or 2 panels, we can actually put one of our turbines up there so that we can actually increase production by 2 to 4 times the amount, because solar is only good for 8 hours a day, and then wind is actually average between 12 and 15. So we have a much longer time. So we are looking for new projects, and we would. the problem with replacing what actually exists comes from a environmental standpoint. It's the current turbines, they're hard to recycle, they're hard to take down. So we want to offer a solution that is that's way better. This turbine has a life cycle of 50 years, but it's also 100% recyclable. It's made with recyclable composites now, and it's made with aluminum. So it's just normal. Actually, it's about 90% because we haven't figured out how to recycle the magnets yet. But that's it.
That's amazing. Congratulations. And you shown from like kind of like the customers that have shown interest from like casinos, schools. So I'd love to like hear who is like your ideal customer, and especially like I feel like governments would obviously like kind of like really take into account this, the US and with all like the resources that are being put into this. So who are you targeting really?
Right now, we're targeting industrial and commercial manufacturing. We have a very large project right now that we're developing in Mexico that will actually help that will help with actual energy independence from their government, because they have their own grid. It's not really serviceable, and they're looking for ways to improve what they currently have. So there's a port in Sonora that wants us to put in a 27 megawatt microgrid system as kind of a, hey, this is actually what we can do. We've also had vast interest from companies like Ford, Lazy Boy, everybody within that four corners of Baja and Sonora, Mexico is actually the third largest manufacturer in the world. And they're looking for ways to get energy independence to where they don't, because when they get a rolling brownout, they turn around and lose millions of dollars because they have to shut down their production line for 2 to 3 days, clean it up, send home people. So honestly, governments would be great. They move really slow. The private sector has been really receptive to this offer.
It makes complete sense. I understand it. It's super interesting. And then because of course you mentioned like Mexico, Tunisia, outside from the US, like are you actually manufacturing the turbines themselves in those places, or like
not
how
yet.
do you manage to? Yeah.
So that's actually one of our unique business models, is that every place that we're going to have a large footprint, like Mexico, Indonesia, we want to bring manufacturing in there as well, so that we can impact local economies, so that we can provide well-paying jobs. We do schooling, we do training, so that we can actually have a positive impact. Because if we're actually manufacturing within the markets that we're servicing, then we actually produce more stimulus for both the local economy as well as shrink our carbon footprint, because we're not shipping all over the world. We're actually producing locally, installing locally.
Makes complete sense. No, I love it. Thank you very much, and congratulations again. It looks super, super interesting. I'll keep you in mind. Thanks.
Thank you.
Thank you, Laetitia. Hélène, would you like to give your feedback? Hélène?
Sorry, I was in mute. Great presentation, Brandon, especially considering you came late, right? So I admire how fast you were able to kind of come in. So I'm fascinated by what you're trying to do, because I've studied the wind energy for a few years. I totally agree with you that a hidden face of green technologies that we sometimes don't look at in terms of full supply chain is both in the lack of being recyclable. There's a big problem for wind industry, right? There's a lack of circular model. So it's great that you actually, your team is thinking about addressing it. And the other one is the concept of material, because interestingly for green technology, because they much more recent technology, we've been using material that are sometimes very hard to extract. So that causes sometimes the supply chain not to be net zero, because it may be net zero at the output, but to make it require a lot of either air pollution or CO2 production. So you mentioned that yours are very interesting when you say you're using recyclable material composed of composite and aluminum. Can you share a little bit about it?
Yeah, so one of the things that we actually looked for was when we first started making this, we're using there's a company that we've contracted with for our aluminum that actually uses a Greentech system to actually produce actually reduce what their carbon footprint is. And then we actually get the sheets, cut them using water jets and lasers and things like that. Our biggest and that makes aluminum is actually pretty easy to recycle once we actually create it. So that's why we went with aluminum versus plastic. We were using a actual marine grade plastic for our early versions, and we found that aluminum was actually better across the board for all of our material usage, as well as the recyclability and greening effect. As of 2021, there were 2 new factories that came on board that can start to recycle wind turbine blades using both that are made from both carbon fiber as well as fiberglass. And we actually reached out to them to create a relationship down the road, so that when we do recycle our turbine blades, we can actually send it to them. They can actually recycle them, grind them up to create a hempcrete mixture.
No, I think it makes total sense. And also the composite material though tend to be much more complicated to get recycled, right? Because you have a matrix you're associating. So you always have to be careful when you start looking into this solution. The other one is, so I think you should probably, in your presentation, I would probably add this aspect, because the fact that you create a circular model, more and more corporations are looking into creating this type of model. So the fact that you are thinking about this, I think you may want to highlight it. The other thing is I like the fact that you mentioned decentralized energy. I think as we're looking, there is a lot of grid fragility all over the world.
Yes.
And so in terms of business model, right? So I'm always looking at IP, because if you have a strong IP and you protect it, that's very interesting for investors, right? There are the risks of the investment. What is unique in your technology? Sometimes in wind energy, it's about, having a better shape of the blades, it's structural, it's material.
It's the geometry of the blades, as well as so our biggest I guess value proposition is that our magnetic levitation alternators are able to create more power from a much smaller base.
I think we have somebody interrupting.
Somebody's not muted.
No, and I think it's fascinating because the thermodynamics of the wind industry hasn't changed for decades. And the fact that you find to think differently, I think it's fascinating. So this part of the
and the fact that we actually put 2 of these, we make a dual wind axis turbine that actually spins in the same stream, and then takes the power produced from both of those alternators, synchronizes it so that we have double the power production in a very small space. We only need 25 square feet, or 2.375 square meters to actually install.
That was another question that I had then, because when I look at your financial, you have a ramp up that is really aggressive. You know, traditionally as an investor or financial person, you will accept like a linear ramp up and then the inflection point and then the rapid growth.
Right.
You will start rapidly, like pretty rapid.
It does.
So is it because of, you think it's because partially because of the size, the design that you have, and you
Yes.
can have a quick adoption?
Yes. Yeah. So the way that we actually look at this, if we bring a industrial client off of the grid and actually give them their own power system, you're talking maybe 1,000 turbines, give or take. So that one client is going to take 1,000 turbines. We can put them in a very small space, produce a bunch of power. But the really unique thing is that as a umbrella, if one of our turbines go down, you're only going to lose about 20 kilowatts. Whereas if one of these bigger ones that's 2.5 megawatts go down, you're going to lose 2.5 megawatts. Whereas we can replace and troubleshoot what we have in less than a day. And it's like a umbrella, whereas instead of the wind coming and taking the whole umbrella out of your hand, you have a pinprick in there now so that you're still producing that amount of power, but it's a very small piece that's been taken away so that it doesn't impact a larger.
And that's what I like in your
sector.
presentation, because both from this angle and the height of your device, when you look at the amount of natural disasters increasing with climate change, you have a good selling point there, I think. So.
That's exactly our, and that was our business model for actually designing these so that they could withstand 160-mile-an-hour winds. That's, I mean, a Category 5 hurricane. That's where the name for the actual turbine comes from. The Cat 5 is because it's rated for a Category 5 hurricane.
Correct. And very often when in terms of natural disasters, that's when typically renewable energy fail, right? Either like sun or wind. So if you have a solution that kind of includes this dimension, I think that's really interesting. So yeah. I think, a great presentation. I think you're like,
thank you.
Congratulations again on such a short notice, but pleasure to meet you.
Thank you.
Thank you so much. Mirjana, would you like to give your feedback?
Yeah, thank you so much, Brandon. This was so interesting. So I would have a few business questions for you, just like for the other startup. And the first,
I will say,
yes,
I am the engineer on the project. My business developer is finance is not my strong suit, at all, as was probably evident by the presentation when we got to the finance section.
But just some basic business questions. They're not very complicated, but why are you better than the competition? So is it because your turbines are smaller and they're more efficient? And then how will you prevent, the big players to copy your product?
How will the last part was, how do we protect them from being copied? Is that okay?
Yes.
Okay, so there's a bunch of things there. The first part, because our turbine, the biggest value proposition that we have is that we actually have 2 turbines in one design. Nobody else is actually out there doing it that can actually produce what we have. Our design's frozen, it's patented. We are constantly looking to increase the actual efficiency from a generation standpoint, which is the actual alternators. We have a patented working magnetic levitation system that nobody else currently has, and we're looking to move that into mass production. And the great thing is that these turbines require 2 of those. So if we get 1 turbine order, we need to order 2. So our sales model is really strong in that aspect. Eventually, we would like to move to PPAs and energy as a service model, but that's down the road. We want to actually establish ourselves within the market now for actual energy independence. And we have a strong patent attorney that works to make sure that we are 100% solid before we move into new markets and things like that.
And is this B2B only, or is it also B2C? And which sectors are you targeting? Because you mentioned hospitality sector in Mexico. Is this your first sector that you want to kind of conquer?
It was the first one that was actually presented to us, but we've gotten a lot more traction. We've had industrial clients come to us and say, hey, how can you help us avoid losing millions of dollars when we have a grid failure? So that was the one that we were targeting, and then we've kind of shifted to the industrial. We're still going to do the hospitality sector, but the industrial is really our biggest push now, because there's so much coming from that sector now that what we thought was going to be a easier sale, we've had to pivot to working with them. Eventually, we will have a residential or consumer model, but to get the price point down to where it's viable for a consumer, we need to have a mass marketing structure or a mass manufacturing structure in place, because these turbines run about $35,000 to $5,000 or $50,000 depending on what energy generation system that they want on there.
And which markets are you targeting? Because you also mentioned the average wind speed. Does that kind of limit your range of markets?
I thought it would until we started doing the actual great thing is that our market research shows that we can actually affect about 88% of the planet because we start in such a small wind environment. We only need 1.5 miles per hour to actually start generating power. That as long as there is a continual breeze, it doesn't even have to be wind. We can actually produce power that is substantial and actually usable.
Okay, that's amazing. And what is your current traction? You said it's really the hospitality, basically the hospitality contract.
Well,
in Mexico.
It was the hospitality, and I probably should have focused more or kind of pivoted to the industrial. We've gotten a lot of the Chamber of Commerce down in Sonora for the actual state. Industrial seems to be the way that we're getting the most traction in, and it's them coming to us. It's not us actually marketing out to them. We've been down to Mexico twice, and we have probably almost $80 million worth of LOIs on the books.
That is amazing. And then my final question, where do you see yourself in 5 years? Like, what is the final big vision?
Well, the final position is that we've actually innovated beyond just small wind and just solar. We want to actually be a innovator in the renewable energy microgrid market, so that we've actually brought remote systems to islands. We've actually helped with the undieselfication of any of these remote remote communities, being a player that actually has had a global impact in helping people that have been adversely impacted by climate change and corporate greed.
That's great. And I also love when you said that you want to help local communities. Thank you so much, Brandon.
You're very welcome.
Thank you, Mirjana. And Sophie?
Hi, Brandon. Thanks for a great presentation. So I think one of my questions goes towards a systems overview, if you will. You mentioned in the beginning of your presentation that you have access to 7 types of energy. And I was curious, how many of those do you develop by yourself, and which parts do you source in from outside companies, partners, or just off-the-shelf components in the market?
The small wind and the alternators that we actually use, those are actually developed in-house. The
Micro
green
hydro
hydrogen,
and solar and everything else, you just source in as you need them?
as we need them. Yeah. And our goal down the road is to actually vertically integrate as many of these as we possibly can. We've been on the lookout to kind of acquire a battery startup, but that's where all of the money is going now. So a small shop like us, we've been trying to find partners that want to continue something beyond that. But our goal in the next 5 years is to actually acquire IP that will allow us to vertically integrate our solutions.
Okay. And then on slide 4, you have this matrix with these 4 different areas. So you have your clean energy generation, and I guess that's where the CAT and CAT 5X fit in. And then you have your energy storage, so that would be your self-alternator, I'm guessing.
Yeah.
Great, I'm wrong. And then you have load efficiency and smart control. So is that software and peak shaving technologies, other things that you source in externally, or is it something that you're developing for yourself also?
We started to, we actually started to develop those in-house, because about 2 years ago when we first started this, I was like, is there anything out there that can actually do this? And I didn't find anything. But last year we actually partnered. We are a channel partner now with a company that was further ahead than actually where we were. We're actually looking to do an IP or
IPO,
a actual equity share with them for the IP. So that is a hardware software model that is based on actual gamification, which it's absolutely amazing tech. And I know the CEO really well. We have a strong contract between us, so that we do have access to their technology as well as all of their development technology coming out. And then the actual energy efficiency side is really a way that we can kind of anchor the client right out of the gate. We have a partner who has developed a line harmonizer, basically a entire building surge protector that goes on the building. So we go through and we actually do a LEED Gold energy audit for them, so that they know what they can do to actually improve their efficiency out of the gate. And then we have client, or we have partners that we then sell them to. So we're both a seller as well as manufacturer.
Okay, that makes sense. And you mentioned also during your presentation that you were able to increase the output from a solar farm by 2 to 4 times. So is that by adding additional clean energy objects like the micro turbines and micro hydro, or is that purely systems control, all of it?
Yeah. We can do it from the actual energy output side. We can actually install the turbines. So solar on average actually produces about 20 watts per square foot installed, whereas our turbine produces about 310 watts per square foot installed. So even by putting in one of these turbines, you're going to increase that solar output by about 2%, about 2 times. Whereas if we can go in and put in, say, 20 of these on a megawatt site, we can actually increase it to about 4 to 5 megawatts without increasing. So solar takes about 1.5 acres, and they can only produce about one megawatt on that acre. We can go in augment what they have and actually increase the output of that entire facility to about 4 to 5 megawatts just by actually installing updated technology from the actual generation side as well as the control side. So they don't increase their footprint, but they actually increase what their magnitude output or what their output is by an order of magnitude of 3 to 5.
Yeah, makes sense. Okay, so between the clean generation, the smart control, the load efficiency, and the energy storage, how do you handle designs of a site? How do you handle, building and installation? How do you handle the operations and everything else? Is that all done in-house? Is that done with partners? Do you source in subcontractors?
Yeah, so our model is to wherever we're actually doing the work, we actually want to go into that community, provide jobs for their local contractors. We'll do the engineering and site plan development, but for all of the installation, all of that, we'll go in and actually train people to actually install these, maintain these, and actually provide long-term jobs as well as construction jobs that are actually short-term, so that the money isn't just coming back to us. It's actually going into where we're actually producing jobs and power, really.
Great. The IP protected parts of your operations within the Cat 5 and Cat 5X and the Cepha alternators.
Yep.
Can they be scaled and marketed separately?
They absolutely can be.
Okay.
That's actually the really cool thing about what we're so the engineering that we have done with the Cat 5 and the Cat 5X is that we've just basically elongated the Cat 5X from the Cat 5. So mathematically, engineering wise, it's really the same thing. It's just a bigger scale, and we are confident we can do that if we have to with other models. With the Zephyr, the great thing is we're only limited by our supply chain. And the biggest piece that we're going to be limited by is going to be the magnets that we use, because right now we can only source them from either China or Russia. So that's our biggest Achilles heel right now in that production. But
do they use neodymium or?
Yes, I believe so.
Okay, yeah, understood. And if you wanted to scale, I think you said that the turbine would need 2 alternators.
Yep. Every turbine gets 2 alternators because we're basically producing 2 turbines in one space.
Right. And would it make sense to increase the size and scale of the alternator? Do you need 2 specifically set up next to each other?
We can. So the Cat 5X can actually hold up to 2 10 kW actual alternators, so that we can get, or it's actually designed to. We need to get into production to make them that big, but we put those on so that if we want to go bigger, if say that we want to put on 2 20 kW actual alternators, we would have to reconfigure the Cat 5X to maybe the Cat 5Z, which will just actually make it bigger. But it's all scalable just through simple engineering and mathematics.
Great. And I think you said that you had a unit to be installed next week. Is that the first one?
Yeah. It's not the first one. It's it is our real world test model. And then we've got probably another 3 installs coming up in the next 3 months that will be our proof of concept or our actual installs that show that we have a working system. And then our proof of concepts are, we've got 2 down in Mexico and 1 out in Catalina Island that that we're going to be doing by the end of summer.
Very exciting.
Yeah.
Thanks a lot. That's all my questions.
Thank you so much for your inputs, and thank you, Brandon, for a great pitch. So this was the final presentation for tonight. So I would like to take the opportunity to thank everyone for joining and for the startups to present. It was really inspiring. I hope everyone enjoyed the evening, and if you like to connect with each other on LinkedIn, it would be amazing, because this is the point of the event, is to network and grow the connections. So thank you to the board members for joining. Mirjana, would you like to say a few concluding remarks? Did you like the event?
Yes, I thought the event was really amazing. Thank you to both startups. I think they're really relevant in today's world that we see that we are living in right now. So I think they both did an amazing job. And yeah, I hope that they will raise their investment soon.
Thank you. It was really great to have you. Hope to see you at another event. Laetitia, a few remarks?
Yes, thank you very much. I wanted to thank you first for inviting me, and I wanted to thank the startups. As it was just mentioned, I think these companies are super relevant. We work at Plug and Play with a bunch of corporate partners, and they keep asking us for solutions that help them with the decarbonization and new solutions for renewable energies. So it was great to hear about you guys. Congratulations and good luck with the round and the future. I'm sure you will make you will have a lot of great impact on climate. So good luck and thank you.
Thank you so much, Laetitia. Anne-Sophie, your last word.
Yeah, thank you so much for a great event to the Startup Club, and thank you so much to Brandon and Herbert for your pitches. It was really inspiring, and I think so relevant. Energy prices are really high right now, and there's a lot of things happening globally, and a conflict not too far from where I'm sitting that's having a pretty big impact. So I think with the renewed interest broadly from industry, regulators, everything, I think you guys should be set up for a good next few months. I'm really hoping so you can roll out these great technologies.
Thank you so much for joining, Anne-Sophie. See you at another event, I hope. And Hélène, thank you for joining tonight. Did you like the event?
No, very interesting company. I like that it's all diversified. Kind of what I love is they are all thinking about a bigger picture, right? In terms of circularity, like what's the next solution, something that would be truly durable and sustainable. So it's wonderful to see founders like having such a global, like being so smart and having such a global vision of the type of technology we need. So thank you for inviting me.
Thank you, Hélène, for joining. All right, so this is the final moments of this event. So I will be uploading the recording on our YouTube channel. So so you can share it or watch it again, or it will be there in tomorrow, I believe. And also check in on our website for more events to come in the future. We'll be having another Greentech event beginning of May, so you're all welcome to join and just get in touch with me for more information. And yes, so thank you so much again, and have a wonderful evening and good night. And bye-bye, everyone.
Bye-bye. Thank you.
Bye-bye. Thank you.
Thank you so much.